We've all seen arrays before. An array is just a block of memory that stores elements that are all the same size contiguously in memory. And then to access an array, we do some kind of expression like this. But why do arrays start at 0? And also, what if I told you that this was also legal in C? Today we're talking about the math behind arrays and why languages that use one-based indexing, Lua, are incorrect. Let's jump right in. When we're programming and we have variables that are all of the same type and convey similar kinds of information, we want to store those variables into what is called an array. And an array is just a block of memory that is meant to house variables that are the same type and the same size that are contiguous together in memory. So to make one, we'll make an int array and we'll call it my array. And to denote that it's an array, all we have to do is put these square brackets after the name. And we can place the size of the array in one of two locations. We can either put it here and not pre-assign values, or we can leave this blank and then pre-assign the values here. I can do 1, 2, 3, 4, for example, meaning I have an array now that is of size 4 and it contains the values 1, 2, 3, and 4. And maybe these are user IDs, maybe these are lines we read in from a file. This can be any kind of information that are all the same type and represent similar kinds of information. When we're talking about arrays, the first question that comes up for a lot of people is, what is the type of this keyword? And you're probably thinking, well, it's an array type. No, it's not. In C, the type of an array label is actually a pointer. We can prove that by printing it right here. So we'll compile the program and then print the array variable. And that array variable is going to be hex 7f something something something. And we can see that it's a stack-based variable because it has this 7f here. That 7f means that it's in the stack on a 64-bit system. So now the question is, how do we use the array, right? Well, like I said before, to get a value out of an array, all we have to do is index into it. And to index into it, we use the same syntax as the assignment, but we put the index that we want to use. Now, to get the first element of the array, you would think we'd use the number 1. But here we actually use the number 0, which is really interesting because why do we even use 0? If I want to get the first element, shouldn't I use the number 1? Let's just compile this real quick and show you that the number revealed here is in fact the first element. Now, the reason that this happens actually has to do with the math that happens under the hood when we use the array pointer. So like I said before, an array is just a block of memory that contains elements that are of the same size, and they're all contiguous, right? This is like 1, 2, and 3, and it goes on until however many elements there are, but this is our array in a nutshell. The base of this array, the keyword we use to describe it, is called my array. Now, under the hood, when we actually want to access elements in this array, the compiler does some math to generate the instructions to get the elements out of it. We use the address of the array, so my array, plus the index you give it, and this is in parentheses here, times the size of the elements, so the size of int in this case, right? So what we're doing here is we're actually saying to get an element in my array, we do my array plus the index times the size of the integer, which is going to be 4 bytes. So when I give it the 0th index, I actually end up doing my array plus 0, which gets us the first element. Because the my array is just a pointer, what I'm able to do is use basic pointer arithmetic to dereference values inside of it here. So by saying the 0th index, I'm saying my array plus 0, which gets us this element. And then the same math applies to get the next element in the array. If I want to get the second element, I actually am going to use 1 because I'm going to index plus the size of the array to access the memory at that location. Pretty neat. Now, that's all well and good, and I think we all agree that that's what's happening under the hood here, but what if I also told you that to get the 0th element of this array, we could do this notation here. We could say 0 of my array. Now, you're probably going to think, no, surely that won't work, right? 0 isn't a pointer, and my array is a pointer, and we're using it as an index. How does that all happen under the hood? And you can even, and we can prove that it works right now by running this command and seeing that we still get, did I actually save this? And seeing that we still get the piece of information that we did before. So how is this happening? How is it possible that we can use 0 as an array and index off by the my array pointer? You may be thinking that it works the exact same way. You're thinking, oh, well, surely the transitive property of addition means that A plus B is the same as B plus A. And while this holds true in math, it actually falls apart in programming. Because I have my array, which in the previous example is equal to 0, and the index is equal to the pointer value of my array. Multiplying that by 4, the size of an integer, would make that array index overflow, and none of this math would work out. We would get some random address, it'd be some value mod 64 bits, and then it would just crash. We wouldn't get to the location that we need to do. It's much simpler than this, and it ends up being a bit of an optimization that the compiler does. So in the event that I have the array of an index, or an index of the array, in both cases, all this turns into is the thing pointed to, the dereferenced value of a plus I, where a is a pointer type and I is a integer type. Now, if I were to flip these, if I made a the index and I the base, at the end of the day, internally, one of these is still a pointer. What's happening internal in the compiler is it's taking the value that is the integer type, the non-pointer type, and it is upgrading it to the index. So it's multiplying it times 4. And in this case, it's multiplying still 0 times 4 because 0 is that index value. So all we have left is I, which is our my array value. What's happening here is not so much of a transitive property of addition thing. It's just the compiler deciding which value gets upgraded to the pointer and which value does not. So at the end of the day, both of these are legal, but not for the reason you probably thought. So this is why I very much dislike languages like Lua. I'm thinking about what's happening under the hood. When I see an array where you index into the first element to get the first element, I'm thinking in the back of my head, well then where is that first element there? Where is the 0th element? Now, if you learned anything here, you'll probably learn something too about why void pointers exist. They're a typeless pointer that actually has a lot of power in the C language. Go check that out right there. See you guys there.